Here we're going to take a look at the inequalities of triangles. So if I have this triangle ABC with side lengths small a across from angle A, small b across from angle B, and small c across from angle C, then what I get is the triangle inequality theorem. In order for it to be a triangle, then side AB plus side BC must be greater than side AC. Side BC plus AC must be greater than AB, and AC plus AB must be greater than BC. To make it really short, two sides must be greater than the third side. If it's not greater, then it's not going to be able to actually be a triangle. And let's look at that. If I had this triangle and I had side length 1, side length 2, and side length 4, could I make a triangle out of it on this line? So I've graduated it with a 0 to 4 so that we can see that. This side length 4 represents AC. So what I want to do is I want to make a side length AB, which is 2. So I'm going to go ahead and line it up at 2, and I'm going to create an arc. Now when my next arc intersects, that's where my triangle would be. So where A is length 1, I'm going to go to the other end of my line and make a length 1 and draw an arc. And what I'm going to see is that since these two lines never intersect, they can never make a triangle. But what if this side was, instead of 1, was a 3? If it was a 3, would this work? So I'm going to take this side length 2 and extend it going in the opposite direction here to see if I can make a triangle. So here's my arc at 2 length, and I'm going to make an arc at 3 length from the 4 on my graduated scale. And I see that I get an intersection. That intersection is what I'm going to use to join this to the 0 mark and to the 4 mark. And I think I'm going to have to go over this with something darker because it's not showing up well for you. So what I get is this triangle. The actual look of that triangle with these lengths would look like this. So we can use this to be able to find different things out. Now as you experiment with triangles, what you're going to find is that this is the longest side of 4, which means that this is the largest angle. And this being a side length of 2, across from the smallest is the smallest angle. So we can see that the longest side across from it has the largest angle. So if I was looking at my original, what I was shown is I can see that AC is greater than BC, and that is greater than AB. Now these are the side lengths, but what it also tells me is that angle B is greater than angle A, and that is greater than angle C. So we're going to have a number of ways to be able to line this up. Now an example that they might give you is they might give you a triangle that's got angles in it or side lengths to it and ask you to simply order them from smallest to largest or largest to smallest. You have to watch out for that language to make sure that you are doing that. Remember, math rocks with a capital M.